All right, so let's get into some more practical examples of this and talk about more interpretation, things like that. So this first example, we have a company that produces snowboards has seen its annual sales increase linearly. In 2005, it sold 31,300 snowboards, and it sold 38,200 snowboards in 2011. Compute the slope that gives annual sales as a function of the year. So remember our slope formula. We have y2 minus y1 over x2 minus x1. So we need 2 points, and that's always the tricky part with these word problems now. We know that sales is one variable and time is the other variable. So sales as a function of the year, y as a function of x. That's how that always works. So y is a function of x. So if you remember that, a lot of this terminology will or a lot of the way these word problems are phrased helps you to figure out what x and y are. Now, time is almost always going to be x, pretty much always. So if you ever have to guess and you have time as a variable, guess that time is x because it almost always is. So we have 2 ordered pairs here. So here is our x1, here is our y1, and here is our x2, and here is our y2. So we have 38,200 minus 31,300 over. Now make sure you get these two in the right order. So 2011, that's the sales with 2011, and then minus 2005, that's the sales for 2005. And we should get 1150. So that is our slope. So now what does that mean? So what does slope represent in this context? So each year, and we'll talk about what this sentence means after we write it. So each year, sales increase $1,150. All right. So think about when we get a slope and we're graphing an equation, we find the point, and then based on what the slope is, we move up and over or down and over, however it goes. So x is the year. So x goes up 1. So the slope would be 1150 over 1. So x goes up 1, sales go up 1150, or you move right 1, you move up 1150. So, so that's basically the way you think of this. You could also put in the units for the slope. So the y units are dollars, and the x units are years. So 1150 per year. Next one, owner of a car wash business estimates that it costs C of X equals 4.5x plus $340 to wash X cars in one day. So what is the rate of change, or what is the slope? Rate of change is referring to slope. What is the slope? The slope is 4.5. And so it cost $4.5. So what are the units? $4.5 per, and what is X? X is cars per car. So it costs $4.50 to wash each car. Now, we didn't, as far as the words, we didn't say this in exactly the same way as I said the last one, but the idea is still there. So, and you could write this, each car costs $4.50. You could write it like that. But a lot of times you want to kind of think of these things, write it or say it in a very plain way. You don't have to say it in a mathematical way. So try to say these things in a more natural way. What does the c-intercept or the y-intercept at c, because the function is named c, what does the c-intercept represent? So the c-intercept is 340, and this is still in dollars. What does that mean? So the y-intercept or the c-intercept is just talking about what is the value of y, or what is the value of c when x is 0. So when x is 0, and this is a very generic way to think of this. This is not the final way that we're going to say it, but just you could always kind of think of the y-intercept as this. When x equals 0, c equals 340. All right, so if x is 0, what does that mean? That means that they wash no cars. So no cars are washed. That's what, when x equals 0, that's what that means. C equals 340, so the cost is 340. And so this usually represents your fixed cost. So whether you wash cars or not, you have $340 in expenses, just based on, paying the people who are there that are not washing cars, paying, whatever maintenance or whatever else you have. But basically, if you have to interpret a y-intercept, this is kind of what you want to say, and then put this problem to that phrase. So again, when x equals 0, that means in this case no cars are washed. C equals 340, that means the cost is $340. So that one's usually pretty straightforward once you kind of remember the idea behind the y-intercept. All right, so another example. As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height h, assuming a linear model is appropriate. So again, we need 2 points. We can find the slope, and then we can find the y-intercept. So what are the 2 points? So t is a function of h, so that is x, and this is our y. So we need 2 points. So ground temperature, so that we're talking about height. So the ground temperature, the height would be 0, and then this would be our y1. So our x1, y1, and then here we have a height of 1 kilometer. That would be our x2, and then a temperature of 10. So that'd be our y2. So our slope is 20 minus 10 over 0. I did that backwards, but that's okay. 0 minus 1. As long as 20 goes with 0, 10 goes with 1, doesn't matter which order you put them in. And so we get our slope is negative 10. Then we need a y-intercept. So remember, the y-intercept is the value when x is 0, the value of y when x is 0. So we know that the value of y is 20 when x equals 0. So that would be our y-intercept. So we have t equals negative 10 h plus 20. And there is our linear model. And if we want to interpret the slope, so the slope is negative 10. So as height increases 1 kilometer, the temperature will decrease by 10 degrees, or temperature decreases 10 degrees per kilometer. They go up. Then what is the temperature at a height of 2.5? So we're just going to plug in 2.5. And we get negative 25 plus 20, so I believe we get negative 5 degrees Celsius. Okay, so fairly straightforward, I think. Again, when you're getting these linear models, you're looking for 2 points typically, unless they give you, actually give you the slope. All right, so the pump has been pouring water into a swimming pool. The data in the table show the water volume at the pool every 2 hours after the pump was activated. Write an equation for a linear function to model the data. So this one, now not all of them, just because you have a table doesn't mean you can do this, but in this case, we go up 2 hours, we go up 300. We go up 2 hours, we go up 300. So this is actually very uniform. These two fit on a line. You can't always trust that will happen when you get a table. So sometimes it's not exactly linear, but it's close to linear. We'll see that on the next one. So the slope is going to be 300 over 2. So the slope, and you could do this. I mean, you could pick any 2 points and do the slope formula, but we do see that each one of these is going up by 300. Each one of these is going up by 2. So 300 over 2, that'll give us 150. And then to get the y-intercept, what would it be, a 0? So to go down 2 more hours, we're going to go down 300. So that must mean that the y-intercept would be 2,500. So we have 150 x plus 2,500. All right, so predict the volume of water after 17.5 hours. So we're just going to plug in 17.5. I forgot to get this calculation. So 50 times 17.5 plus 2,500, and we get 5,125. Now, this is one where, well, I guess, I mean, you could think of this. Anyway, it's always a good idea to kind of think of, does your answer make sense? So if we look at our equation, does our answer make sense? The water is going in, so the slope should be positive because the water volume is going up. 2,500, you might think it should be 0, but it doesn't say that the pool started empty. So definitely we should not have a negative number for the y-intercept if we're talking about water in a pool. And then this one, after 17.5 hours, 5,125 gallons. That seems to make sense based on the trend that we have. So after 10 hours, there's 4,000. So obviously it's going to be more than 4,000. So that seems like a reasonable number. And then when will the amount of water reach 6,000? Just thinking about this one. Oops. Think about this one. If after 17.5 hours, there's 5,125, obviously this number is going to be more than 17.5. So this is our y, and we are looking for, oops, and we are looking for x, the when. So 6,000 equals 150x plus 2,500, and we can solve that for x, and I'll skip the algebra steps, and we get 23.3. So after 23.3 hours, 23 1/3 hours, to be more precise, we'll have 6,000 gallons. All right, and then the last one. So here we have a scatter plot. We have data, we have scatter plot. So the table gives a lot of data points. And now notice on this one, we're going up by 2 years, it looks like every time. But these differences are not uniform. And you can tell that by the scatter plot. This is pretty close to a straight line, but it's not exactly straight. You can tell that just kind of looking closely, which means that these are not the same distance apart. So what we want to do, we want to find a model for the CO level using, and they'll give you 2 points, but you could kind of pick any 2 points. But we're going to pick the points. So that'd be 1984, that'd be 2000. So 1984, 2000. So find the slope between those 2 points. And so let's see, we have 369.4 minus 344.4. That's over 20 minus 4. And that gives us 1.5625. So that is our slope. So now with this, these points may or may not be on the line. So if you draw a line through this, not every point is going to be on there. Maybe none of them actually are on the line. Maybe they're all pretty close, but maybe none of them actually are on the line. But you cannot assume that this is your y-intercept. So we're going to have to go through and let's do this with slope intercept or point slope form. So let's put one of these points in. So let's do C minus 344.4 equals the slope. And then T minus 4. And so all we did is point slope form. So y minus y1 m x minus x1. So we have the point 344.4 and then the slope. So let's solve this and we'll skip the algebra again. And we should get 1.5625 t and then plus 338.15. And that is the model that we get. And so you can see the wire said 338.15 is not what we have as the actual data point, but it is close. And the reason for that is because we're using that point and getting the line between those 2 points, which may or may not go through any of these other ones. So all we know is it goes through those two, but we don't know anything else. Or I mean, we can figure it out, but it's not guaranteed that the line will go through any of the other points. So, so the next video, we'll get a video from YouTube and talk about how to get a regression equation based on a scatter plot like this. So if you have any questions, feel free to email me and I'll get those as soon as I can.